and far vision, and I speak you that we have an important process named accommodation that adjusts the place of image formation on the retina. And we say that when we see a distant object, so accommodation is inactive and the images will be formed on the retina, and when we see or gaze on a near object, so the accommodation will be activated to again focus the images again on the retina. So accommodation is very, very important. And we say that we have another important organ, iris or pupil, that it adjusts the level of light entering to our eye by contracting the circular muscle of iris, so the level of the light that comes through our eye will be decreased, and by contracting the radial muscle, so the size of the pupil will be increased and the more light will enter into the light. And we say that in the retina we have two types of the cells, cones and rod cells. Every one cone is connected to one relay nerve cells, and 2 or 3 rods connect to one relay nerve cell. So resolution and definition for cone cells is better than the rod cells. And finally, we speak about the rhodopsin sensitivity, dark adaptation, spectral response, and today we start by color blindness. Color blindness, it is a new course. Color blindness is caused by shortage of a particular kind of the cone. Shortage means that a problem in the function of the cone cells. If you remember, we have 3 types of cone cells: red cone cells, green cone cells, and blue cone cells. That each cone cells respond to a spatial part of the electromagnetic spectrum. The failure to distinguish between red and green is one of the more common ones, especially in the man. For distinguishing the color blindness, we have a standard test. Its name is Ishihara test. Ishihara tests are some charts including the color dots, and the patient must resolve some numbers, and the physician asks the patient if you see a particular number in the picture, yes or not. If the patient say yes, or if the patient name the number, so he or she has not any problem. But if he could not discern any number, so he may suffer from the color blindness. For example, in this picture, if the patient is normal, so patient can read 25, 29, 45, 6, and 8 in this picture. But if the patient has the color blindness, red and green, or red and green color blindness, the patient can only read 25 and 56 number, and the number in this picture, in this picture, in this picture, and this picture cannot be read. So there is a problem. It is a standard test for the color blindness. You can also find in the internet the application for color blindness. There is some question about diagnosing, discerning the numbers hidden in the picture, and the application asks you, please read the number, and finally after 20 to 30 picture, the application says you that if you have color blindness or not. Okay. Another important problem and parameter is the resolution. Resolution means tafkik. In Arabic, I think it is tafkik. Resolution is the ability of eye to discern or dissolve the details. Is a very important factor in the vision. Resolving power is defined as the minimum. Please notice. Resolving power is defined as minimum separation angle of two objects that can be separately distinguished. It can be shown that resolving power or resolving angle is obtained from this formula. Theta or sinus of theta equals to lambda over d, where d is diameter of the eye. D is the diameter of eye lens, or diameter of iris, or diameter of pupil. And lambda is the wavelength of light entering to our eye. It means that when the diameter of the pupil or diameter of the iris is increased, this angle will decrease, and it is good. If the wavelength of the light is decreased, again, this angle will be decreased, and it is good. If the resolving or separation angle increase, it is not good. And if the separation angle decrease, it is good. Visual acuity. Acuity means haddat. Okay, is defined as inverse of the angle. Inverse of the angle by which the two nearest points are separated. That is, visual angle equals to 1 over theta per minutes. Okay. For example, if we know that the separation angle for an eye is half a minute. Minute is the degree of angle, not the unit of the time. Okay. 1 minute is equal to 1 over 36 degree. Okay. For example, I want to write for you an example. For example, if the separation angle is for example is 0.5 minutes, so visual acuity will be 2, okay, and it is very good. This separation will depend on I'm looking for. This separation will depend on the structure of the retina. If the distinction between 2 points of the light is to be made, then there must be at least one unestimated receptor. I will explain for you. Cells between those stimulated. Hence, minimum spacing will be twice the diameter of the receptor cells. You see here it is the construction of the eye. Please notice to this, it's an important picture, please. Notice to this picture. It is one point and it is another point that our eye want to be separate, want to see separately. Okay, it is the angle between two objects. Okay, when two objects gets close to each other, so this angle will be decreased. Okay, and it is very good. If our eye can resolve two near points, it is a good capability of our eye. So it depends on the size of the cone cells here. Okay. Yes, for dissolving or for separating two different points, one cone cells must be activated, one cones must be activated, and one cone between two activated cells must not be activated. Okay, and it is twice the diameter of one cone cells. The minimum space for a normal eye. The minimum distance between two stimulated cone cells that must be activated for a normal eye is 1.5 micrometer in a normal eye. But if there is a problem, for example, the patient have myope or hypermetrop, this angle will be decreased. So visual acuity will be decreased and it is not good. Okay, so for a normal hair, when the size of cone cells decreased, the separation angle will decrease and it is good. Okay, and so on. The optical system. The ability of eye to form images is a result of refraction, please notice, is the result of refraction at the curved interfaces between various media that light passes through on its way to the retina. Refraction power in diopter, unit is diopter, is equals to 1 over focal length. So when the focal length decreased, the power of the system will be increased. Focal length units is meter. Okay. The power of a series surface can be added algebraically. In our eye, we have retina, we have aqueous humor, we have lens, we have uterus humor. Every separate compartment of our eye has its refracting power. So the total power of our eye will be sum of the different refracting power of each component. Okay. The amount of refraction is independent on the change in the relative index at the interface, which is greatest at the front of cornea. In this picture, you see the construction of our eye. It is air, it is cornea, it is aqueous humor, it is lens, and it is vitreous humor. Every surface have its own refracting power. The greater refracting power is here, the interface between air and in the cornea. You see the refracting power is 46 diopter. Here the refracting power is minus 5 diopter. Here the refracting power is 18 diopter. So total power will be sum of the 46 minus 5 and 18 diopter. And finally we have 59 diopter. Okay, we only add this number and the next number. Okay, here you see the refractive index of the different component of our system. It is 1 is the refracting power of air, 1.3 is the refracting power of cornea, and so on, 1.33 and so on. The greatest difference is here between 1 and 1.3. You see here we have the greatest difference. So the power of the refraction here is the greatest relative to other parts. Okay, so this part is very important. In front of cornea is very, very important. Accommodation. Shape of lens is variable. Shape of lens is variable. So it has adjustable focus. When the lens is at its flattest shape, it has a power of about 18 diopter. It is the minimum power of our lens. This is for producing an image on the retina of the distant object. When we see, please notice to me, when we see a distant object or accommodation it as minimum level, the power of our eye will be 18 diopter. Now we are observing a far point. So if I ask you where is far point, you say to me the far point is the farthest point that we can see clearly without any accommodation. Okay. In contrary, we have near point. the nearest point that we can see with maximum accommodation. Okay, to focus on a closer object, the lens needs to increase its power to coverage the beam. In young people, the maximum power is about 29 diameter to produce a near point. The nearest position of a clear vision for an adult man is 0.25 meter or 25 centimeter. And the far point for adult, for a normal man, is at infinity. And for a normal man is at 25 centimeter. Here you see the process of accommodation. Range of focus at distant object. You see it is a distant object. The light ray comes from infinity and reaches the eye, and here the lens is at its flattest form, and we have no accommodation, no tatabuq, and you see picture or image is on the retina. But when the object gets closer to our eye, the light ray gets diverged, and so the lens, the accommodation of the lens must be increased. When we see the nearest object or near object, I say you that for a normal man is at 25 centimeter. Again, the image must be placed on the retina. So it is adjustment of our eye between minimum accommodation and maximum accommodation. Here again, minimum accommodation, you see that the lens is at flat form. And here the lens is at the curved form, at the round form. You see here the ligament between ciliary muscle here is relaxed, but here is contracted. Okay? Okay. It is for distant vision, for distant object, and it is for close vision and for close objects. Power of accommodation can be calculated from difference in power. Power of near object for near vision minus power for far vision. It means that 29 minus 18, of course for a normal man, in above example. So power of accommodation in our example is 11 diameter. Okay. In young children, the power of accommodation may be as high as 40 diameter. In elderly people like me, it can fall to 0. Another important parameter for our eye is depth of field or depth of field of vision. For any particular focal length, objects at only one distance will form a sharp image. Okay. In practice, there is a range. It is a range, not a point. There is a range of object distances which can produce an acceptable clear image. This range of distance is called depth of fields. So what is depth of field? This depth of field is a range of distance that give a clear image. It is much greater for distant object. I mean that for distant object, distant, not close. For distant objects, we have a greater range of clear vision. But for near object, the range of clear image will be decreased. The lens is the depth of field. Here, it is depth of distant object and it is near object. Here, you see that at this range, for example, from here to here, the vision will be clear for this range. But for here, you see that the distant object here, the range of clear vision is less. Only this. Why? Because we have a small divergence. But here we have large divergence. For depths of field will be decreased here. But here we have a greater range of vision. Another parameter is depth of focus. The divergence of rays from an object can be reduced by reducing size of pupil. When the size of pupil or iris is decreased, the divergence of ray will be decreased. So again, the range of vision will be better and will be more increased. This increases the range of image distances that can be accepted by retina as a focused image. This is called depth of focus. Here, in this object, you see when the size of pupil, it is the size, here is pupil, okay? When the size of pupil is increased, so we have greater divergence. So the depth of field will be decreased. But here, when the size of pupil is decreased, so we have less divergence. And here we have the greater depth of field. I hope you understand. Depth of perception, another parameter. Perception is a complex process using not only the image on the retina, but also the brain's memory to interpret a scene. Familiarity with a scene or object viewed and with the effect of perspective can help avoid limitation of monocular sight. Monocular means seeing by one eye. Okay, binocular means observing by two eyes. When we see by two eyes, we have the capability of perspective because we are observing the environment by two cameras, okay, with different angle. We have perception of depths. But when we have one eye, we lose the capability of perspection, okay? But by using of our memory, but by familiarity of our brain in the scene, we can have again, just by one eye, the capability of the three-dimensional perception. In binocular vision means that using of the two eyes, each eye has a slightly different, please, you can put your hand in one eye and another eye. You see the image moves, okay? It is because that our camera is changed its angle towards the objects, okay? Each eye has a slightly different view because of its position. The brain is able to compare two images to perceive the third dimension, depth, a stereoscopic effect. It is named a stereoscopic effect. Okay, optical acuity or head depth. I don't know what is in Arabic, optical, I don't know. In addition to perceptual limitations of the retina, discussed above, the sharpness of the image is limited by optical factors. We have three optical factors that in contrary to clear image. Okay, there are physical problem. It is not due to our eye. Also in the microscope we have this problem, in the telescope we have this problem. They are physical problem. The first problem is the chromatic aberration. Chromatic aberration is the blurring of image due to the light of different wavelengths being brought to the focus in a slightly different position. It means that as the white light has nearly 7 wavelengths, okay, every wavelength has its own refractive index. So every light, every color has its own focus distance. So we don't have a unique focus point. We have a range of focus. Okay, and it is not good, because refractive index depends to wavelengths, and the white ray and the normal ray that we live in within it have different wavelengths. So we don't have a focal point. We have a focal sphere. We have a focal space. Another problem is spherical aberration. Is the result of a wide beam of light entering the eye and being brought to a focus in a different position. This will be more serious when the pupil is larger. It is because the curve of our eye, and when the refractive object has a curved surface, every light that strike the cornea, that strike our eye, have its own refracting power. So again, we don't have a focal point. We have a focal range. And finally, refraction occurs as the light passes through the pupil, being more pronounced as the aperture becomes smaller. It is a physical phenomenon that we say that when the light enters to a small orifice or a small point, when the light comes through, it diverges. Okay, it does not continue its path in a straight line. It diverges, and it is not good for focusing an image. You see here the problem of the chromatic aberration. You see, here we have light, white light. When it is focused, you see that the blue light focus here, the green light focus here, and the red light focus here. And we don't have a unique focus point. We have an area. It is an area. It is focus spot. It is a focus area, and it is not good. When the lens is angled, we have this point parallel together. Okay. Again, we don't have a point. Here it is the spherical aberration. You see that the incident angle for every light ray, for example, this, and this, are different. And every converging light both on the focus at a different position. Okay, and again, we don't have a focal point. We have a focal area, and it is not good. Okay, now we can speak about optical defects and their correction. Sorry. There are 4 common types of defect in the image formation by the eye, which can be corrected by spectacles or contact lens. There are failure to produce a sharp image of distant object or near object, myopia, hypermetropia, failure to accommodate presbyopia, and failure to focus in a certain place. It is astigmatism. First, myopia. It is very important, and I have many problems for you in our examination. Myopia, another name is short sight. Short sight. In myopia, near objects are clearly seen, but the image of the distant objects are formed in the front of retina, causing blurring of distant vision. The farthest point that we can clearly see has moved from infinity, to somewhere quite close to eye. So the range of vision has moved toward the eye. You know If I ask you, where is far point for a normal man? You say me, you answer me, it is at infinity. But for a normal man, for a myope man, for a short-sighted man, the far point comes closer to the eye. For example, at 6 meters to the eye, at 5 meters to the eye, at 1 meter to the eye. When the far point is not at infinity, so the patient is myopia. In effect, the power of eye is too great, and the problem is corrected by a diverging lens with a negative power. So I mean that when we put a diverging lens in front of an short sight man, so the power of the eye will be decreased and the place of the image will move toward the retina. This red line is very important. We want to calculate the power of correcting lens. How we can calculate the power of correcting lens? This is calculated by finding, please notice, it is very important. This is calculated by finding the power of eye at its far point. First, we calculate what is the power of eye when the eye observes the far point. We know that for a myope person, the far point is not at infinity. Then selecting a lens with a power to move far point to the infinity. Okay, so first we calculate the power of eye at the normal condition, and then we calculate of the power of the spectacle to move the far point to the infinity. That the patient will be normal. Okay, it is a short sight person. We put a diverging lens, a negative lens, a muga'ar lens, and when the parallel light enters the lens diverges the light and move this point to this point. When we don't have the correcting lens or diverging lens, the parallel ray, when enters the eye, they focus here, and it is not good. It is a myope person. When we put the diverging lens, the focus point will move to here, and it is corrected. Okay. For example, it is diverging lens, its power is -2 diopter. We put here. It diverges the parallel and focus the ray on the retina. It is correction of short sight, A, B, correction by convex lens, and effect on the far point, See, if it is the far point for the myope person, and when we put the lens here, the far point goes to infinity. And effect on the near point. When we don't have correcting lens, the near point will be here. And when we put correcting lens, the near point will be here. So the near point gets farther from the eye. Now we have examples. Please notice, we have a very, very important formula for all of lens. We say that if, please write in the paper, if the focal length of a lens is f, if the distance between object and the lens is u, and when the distance of image to the lens is V, we have this formula. 1 over F equals to 1 over U plus 1 over V. Again, I say for you, F is the focal distance of the lens. U is distance between object and lens. V is distance between image and lens. Okay, so 1 over F has another name. Its name is power. 1 over F and P are same. P is power of lens. Here we want to speak about OI, and here the lens is lens of OI. 1 over F is power of OI. U is the distance between object and our my eye. D is the same as V, is distance between image and lens. And you know that in our eye, the image is under retina. And we know that the eye lens distance to retina nearly for a normal man is 0.02 meter. It is the distance between lens and retina, or the distance between image and the lens. Okay, it is our example. Consider a man whose far point is 0.5 meter. Far point is the farthest object that the man can clearly see. Okay, it is U. Okay, the power of his eye when is fully relaxed is this. We can easily calculate this. U is 0.5 meter. V is fixed number, the distance between retina and lens. It is 0.02 meter. When we calculate this, the power of eye at relaxed condition is 52 diopters. 52 diopters. Okay, it is when the eye is not corrected, when the eye has a problem, when the eye far point is at 0.5 meter, but for a normal man, the far point is at infinity. To have this far point at infinity, the man needs the power to be when the eye is normal, when the U is at infinity. Okay, 1 over infinity plus, this is fixed, 1 over 0.02 meter, it is equal to 50 diopter. It is a normal power of eye, but the power of eye is 52. So the correcting lens must be 50 minus 52. The correcting lens will be minus 2 diopter. The eyeglass power will be minus 2 diopter. At this condition, far point will go to infinity. I hope you understand. Okay. A short-sighted person will typically have near point closer than normal. It is the problem for near point. Suppose the man has an accommodation power of 5. You remember that accommodation power was the power of eye at near condition minus the power of eye at far condition. Okay, Pn minus Pf equals to 5. So his power at near point will be 52 plus 5 equals to 55. 52 is this number. It is the power of I when the short-sighted person looks to far point. When we add the power of accommodation, so 5 is added to this number. It is the power of I when the eye focus at near point. And he will focus at a point N. We want to know where is the near point. Okay, it is very simple. We know what is Pn. It is 55. It is the power of I at near point condition. 1 over N. N is the distance between near point to the eye plus 1 over D. 55 equals to 1 over N plus 1 over 002. And finally, we will have the N at 0.14 meter. And it is not normal. And we know that for a normal adult man, near point must be at 25 centimeter. Here is 14 centimeter. We and the lens will move the near point further away to N prime. N prime is a near point at normal condition, and we know it is at nearly at 25 centimeter. The power is now that of I at maximum power combined with the lens. Pn prime is equals to Pn plus minus 2. What is minus 2? It is the power of correcting lens. The new power of I will be 55 diopter. So the new near point is given by this. Pn prime equals to 1 over N prime plus 1 over 002. That is 55 equals to 1 over N prime plus 50 diopter, which gives the new near point 0.2 meter from the eye, and it is okay. The man may wish to remove his spectacle for close viewing. It is normal. Okay, it is the condition of the short sight. Okay, I want to come back to you. Do you understand? There is no sound. You cannot hear me. You cannot hear my voice? I can hear you. Okay. So Muhammad, I think your system have problem because another student say me that he or she can hear my voice. Do you understand my course, students? My student, do you understand? The problem of short sight? I hope. Only one student understand? Okay, if you understand, please write 1 for me. If anybody understands my class, write for me. Not clear, I don't know why. I don't know, doctor. Okay, please again read the course, read the slide, and in future can ask for me. Okay. Of course, the course is I think it's difficult to understand, and we are not close to each other, and you must ask me, and I might write for you the another problems, and we can explain. But here at this condition, it is very very bad. Sorry, please, I want to... Okay. Wait a minute, please. الو من تو کلاسم رفته؟ آها باشه حالا ببینم چی مشکل شد. مرسی. Okay. Another problem will be hypermetropia or line sight. Do you hear my voice? Do you have a social networking that I can continue? You can ask your question by my email. It is my email. I write for you. Okay, and it is my number, and I'm in the WhatsApp application. I'm in WhatsApp. Okay. I'm in the okay, do you understand? You can find me in the WhatsApp application, and also you can send me an email. WhatsApp application. Okay? This application, I don't know what is WhatsApp application. You can find me and you can ask your question. Okay? And you know, we can, and I can give you through WhatsApp my file again. Of course, the faculty of medicine will give you the slides. Okay. Hypermetropia. Hypermetropia, in the hypermetropia or line sight, distant objects can be seen clearly, but the eye is insufficiently powerful to produce an image of nearer objects on the retina. It is in contrary to myopia. The distant object can clearly seen, but the eye is insufficiently powered to produce an image of near objects on the retina. The range of vision has moved out from the eye. In the myope, the range of vision comes close to the eye, but in the hypermetropia, the range of vision comes far from the eye. It is a common problem in infancy when the eyeball is too small for the optical system. It is corrected by an additional converging lens with a power which will bring the near point to that of a normal eye, 0.25 meter. Again, it is corrected by additional converging lens with a power which will bring the near objects to that of a normal eye. For a hypermetrope man, for a line sight man, near objects will move to, for example, 0.5 meter to 1 meter to 3 meter. Okay, you see that a line sight man, if wants to see his mobile, his cellular phone, moves far from his eye. Okay, it is a line sight man. When I put my lens, okay, so I can see my phone at the near distance. Okay, so my eye is corrected. Okay, when I see my lens at 0.25 meters, so my eye is corrected. Consider a woman whose near point is 2 meters from her eye. Near point is 2 meters. We know that near point for a normal man is at 0.25 meter. The power of her eye is 1/2 plus, you know this formula. 2 is the distance between object and the eye. And here, this distance, we are speaking about near point. Near point is at 2 meters. It is distance between lens and the retina. It is fixed for any eye. Okay. At this condition, when the near point is at 2 meters, the power of eye will be 50.5 diameter. To focus at this normal, it is normal distance, she will need a power 1/, it is normal near point, 0.25 plus 1/002 meter. So it is normal power for observing near point, 54 diopter. So the lens must provide a power 54 minus 50.5. So the lens must provide a power of plus 3.5 diopter to give her a near point of 0.25 meter. It is correction of the long sight, correction by convex lens. It is convex lens for a long sight person. Effect on the, it is correction effect on the blind side. It is a effect on the short or near point. You see, when we don't have any lens here, the near point will be here, and when we put the lens or a converging lens, I means that its power is plus. Here in our example is 3.5 diopter. The near point will move toward the eye, and it is a normal. Why? Because the patient wear the positive correcting lens. Okay. The presbyopia or old sight. With the age, the lens loses it is the problem for old man like me. With age, the lens loses its flexibility and the power of accommodation. There is also a weakening of the ciliary muscles that control the lens. Older the people may require a lens for both distance and close viewing. This can be provided as bifocal spectacle in which the upper part of lens is used for distant vision and the lower part for near vision. For the presbyopia patients, the eye is fixed is adjusted for at a fixed distance, and it is problem. They wear a bifocal eyeglass that the upper part has a lower power and the lower part has more power. So upper part of the lens is used for far sight, and the lower part is used for the near sight. Your father and your mother may wear this type of eyeglass. And the final part is the astigmatism. This is usually caused by cornea not being spherically curved. It is the condition of the most of the humans when the cornea is not symmetrically curved. Okay? So that it has different curvature in the different direction. Images are seen in the sharper focus in one direction, for example vertical, than in others. It is corrected by lenses that have a cylindrical curvature in the correct orientation to compensate the cornea. This is often combined with a curvature to correct the short and long side. Many times the patient may have astigmatism plus hypermetropia plus myopia. It is the condition of astigmatism. The power of at vertical direction and the power at horizontal partition are not same. So you see that the vertical ray are focused here, but horizontal ray are focused here. So we have many point of focus, okay? And it is corrected by cylindrical lens. And of course, we don't speak about, we don't speak more about the astigmatism and cylindrical lens. And it is a system for diagnosing the astigmatism, because the patients suffer from the astigmatism, see better or can dissolve lines at a certain direction, and another direction cannot dissolve the lines or differentiate the lines, and it is corrected by cylindrical lens. And finally, contact lens. These are lenses placed in the surface of the eye to perform the same function as a spectacle lens, especially for the women or the girls that it is important cosmetic problem, and they don't like to seem to wear eyeglass. They prefer to use the contact lens. There are two main kinds, hard and soft. Hard lenses are made of rigid plastic, but about 1 millimeter thick and 1 centimeter in diameter. They are separated from cornea by a layer of tears. This enables the lens to take up an orientation which can compensate for astigmatism. It is the contact lens. Okay, today our class is finished. If you have any question, at this time we don't have any examination, but at the end of the second course, a course about X-ray, we can have examination. Okay, please wait and please read the slides, read the files, and I take your examination. Of course, we must speak with the Faculty of Medicine, with Mrs. Haydari and the other man responsible for this. Okay? Inshallah, you have a good week and you have a good day. Khuda Hafiz.